Now, this is your textbook, the chapter 9, the right trigonometry. Okay, so let me start it from what I say. I'm sorry, not this one. I want this whiteboard. Let me put this to a new tab. Okay. Oh no, I should move it out. It's a separate tab, separate window. Let me just use this one for a whiteboard. Okay. Now, the textbook said the textbook actually say the right triangle trigonometry. Okay, so you talk about the sine, the cosine, the tangent, and secant, and cotangent. This different number, right? So this one is called hypotenuse. Yeah, hypotenuse. Hypotenuse, and this one's opposite side. This one's the adjacent side. You know, whatever it is, that's the name the school will call. Then let's look at this. We have this, right? So basically, let me change it to bigger. This one. So basically, if it is the sun, you actually have sunshine from this direction. And this one actually is the projection you got on the x-axis projection. Of this hypotenuse, right? It's actually called cosines theta, if this is theta. Okay, its projection on that angle is called cosine. And then if we have this whatever triangle, we have a theta here. You write this cosine. Is that okay? Yeah. Here I have this, the angle here. You write a cosine. So the ratio between this one and this one is called cosine. Is that okay? Cosine of this theta. So this is cosine theta. So A over R is called cosine theta. Same thing, this one is R, this one is A. We call A over R is called cosine theta. Now I'll give you another thing. So I didn't teach the same way your teacher may be teaching you, okay? So right here, I have some right angle like this, right? Okay, let me do this. Let me do this. I'll be copying the link. Okay, copy the link, and then pause on. I should pause on this one. Okay, I pause on your mom's Facebook. Okay. Now, do you have a separate Facebook or what?
I have a Facebook.
Yeah, can you give me the Facebook? I add you as friend. So otherwise, your mom will see a lot of these course stuff.
Okay. I don't use it a lot though.
But you can just use that for this class. Or you use do you have a Skype or something?
No.
No. So what's your name for that? Also Ashley.
I think it's just Ashley.
That's it.
Ashley.
How does your teacher always spell? This is San Jose one?
I think.
With no level?
Yeah.
So let me add this friend. One mutual friend. Who is a mutual friend? Let me check. No, you have mutual friend. This is a mutual friend. If the mutual friend is your mom, I think. Okay, that's you.
Okay.
Then you actually just let me put the message so that actually, yeah, there's a whiteboard link. You click the whiteboard link over there, and then you will be able to write something on the whiteboard I put on. So now try this. Try to draw. Okay, here I give you this side. So which side will be the cosine side?
Or which one?
Or the one I show you here, this one. Which one is the cosine side? If I have a theta over here.
Oh, it's the bottom one.
The bottom one?
Right?
So now if we have this, the angle is over here, and this one's theta. Which one is this? It has a and a prime. Which one is the cosine side? This is r.
Cosine size A.
Okay. So this one you can always find it by c cosine. Right?
Mm-hmm.
Now let me talk about sine. This one is called cosine. We have good enough understanding about cosine. And I pass to your this one. Okay, I pause here. Okay, now I clean this. Make the eraser bigger. Now I have a right triangle like this. My theta is over here, and then this is r, this is b. B over r is called sine theta. And when we write sine's cursive is what? It's like this, right? Capital case. Or you sign this. Right?
Yeah.
So it's like this. So this side is sine. When you have a theta over here, you write a sine. This side is b, that's the sine. So that's, I'm sorry, not this one. If we have a triangle like this, right? I have a theta over here, and then say 1, 2, 3. Which side is the cosine side? Can you try to use the whiteboard link to write something on my board? You are supposed to be able to do that. Can you try? So next time you can actually write something on my board as well.
Oh, I think I joined it.
Yeah, you joined it and then you try to write on the board. Write on the board. Write your name or whatever.
Oh,
Yeah.
whoa. Okay.
Oh, that's okay. No, don't worry. I can move around. But okay. Now try to draw on here.
Okay.
Try to draw on there to show me which side, which one is the sine side.
Okay, the sine side is the second one.
Second one.
This is jaw.
This side is this is a sine, right? This is cosine. So when you write a C, that's a cosine. Write S, that's the sine side. Is that okay? That will make you easier to remember which one is which. Okay? Okay, so I teach you two things. One is first one is cosine is a projection on the x-axis. Now this one, sine is actually your projection on this y-axis. Okay, on this y-axis. Now I'll clean this. Next one. This one is that we have this, I call it circle, human circle. The radius is 1. And then here we have a theta. So this is called cosine theta because it is actually cosine over 1 equals this x over 1. If this point is x, y, okay, and the circle, the length of this is actually 1. This one is 1. We call this 1. And then this x is actually x over 1. And it's exactly cosine theta.
Okay.
Right? And then the other one, I use the red one. Here, that's this y. So this is sine theta equals y over 1 equals sine theta. Okay? Now, we have another proof one. It's longer to another point called A and B. Right here. And the length of this one is R. So the distance A over R equals cosine theta as well. And then A equals R cosine theta. Okay. Same thing this side over here. B over R equals sine theta. And then B equals R sine theta. Is that okay?
Yeah.
So what do you feel about sine cosine right now? How's your feeling about these two things?
I think that's pretty simple.
It's actually two things. Number one, sine cosine are projections. That's
Okay.
what I want to actually let me see, this one is yours. Okay. Number one is a projection. Number two is actually some sort of ratio. Some sort of ratio between the side of some triangle. So it's some sort of ratio and it's some sort of projection. Okay. Now I'm going to erase this. So right here, I draw another circle over here. This one is 1. a bigger circle over here. So that's this point, call this point as A. Is H is AB. This is B point. This is C point. This D point. This E point. So triangle CDE and triangle CAB. Actually, these two are similar but not congruent, right? They are similar but they are not congruent. But the ratio is the same. The ratio is the same. This length is R for this radius, and this is A, and this is B. And then here, this one's cosine theta, this one is sine theta. The ratio is the same. So actually, A over R equals cosine theta. And then B over R equals sine theta. Right? So sine, cosine are both ratios. Both are ratios. Okay. And also, if you draw a triangle, any triangle here, if the length of this guy is 1, one side can be sine theta if theta is over here, cosine theta if theta is there. And if I have an angle phi over here, this is 1, this will be cosine phi. This one will be sine phi. Right? Okay, so that's actually some sort of ratio. Now another thing I'm going to talk about. So sine, cosine are both ratios. They are both ratios. Wait, let's do the page. Okay. Now, let me draw another thing. Here we have this y-axis. We have this x-axis. Okay, we have a circle like this. And as I mentioned, this one's 1. So here I have a theta over here. So the length of this guy is called cosine theta. The length of the other guy over here is called sine theta. Right? Now I use blue. The length of this guy is called theta. The arc. Theta is also a ratio. Okay, theta is also a ratio. Cosine is a ratio. Sine is a ratio. Theta is also a ratio. So my circle, okay, when people teach you circle in elementary school, they told you this is 360 degree. Why 360 degree? Why not just 120? Or give me 100 degree? Why people use 330 degree? Because they are too old? Because they are Egyptian? Or what?
I
Why?
don't know.
Anybody teach you why they are 360? Let's try use this. Never think about this?
No.
Because Egyptian, I told you, right? It's too early. Okay, so the problem is some sort of related to Egyptian. Why Egyptian? Because at that time, ancient time, they are not accurate in knowing about, they are not very accurate in knowing about how many days are in a year. So they see the sun go around, they believe that the sun go around the earth at that time. So they believe that the sun travel from north to south, south to north. Every year you have winter and you have summer. They estimate it is around 300 days a year. And then they kind of use that to believe that, okay, the sun go around so it takes you 360 days. So let's assume that it's 360 degrees for a day. And then later, this Egyptian also in about 1,000 years later, they divide it into 24 hours. They divide it into 24 hours. They got a 360 degree circle, and then they divide it into 24 hours, right? By ancient time, they do not use a cell phone to keep their hours, right? So what did they do? What do they use for keeping the hour? Knowing that what time it is right now, what the ancient people used to do that. You have no idea? Okay. Or it is a very strange Chinese word. It's called sundial. Okay? That's called sundial. So a sundial look like this, right? So by the shadow, you divided this into 360 degrees. So look at the shadow on which angle it is, you know what time it is. So that's a sundial. All ancient people use that as a sundial. I use sundial to keep hours. So they further divide it into, it's 24 hours. So it's actually, each hour has how many degree?
Each hour has
360 divided by
24.
By 24, that's about 15. Right? That's about 15. So they actually, within an hour, they cut 15 cut over there. Right? That's final one. That each one is 1 degree. Okay, that's how ancient people keep time. So 360 degree is a ratio. It's a ratio between your 1 day and what? An hour. An hour have 15 degrees. So it's a ratio, but the ratio at that time when they use it to keep hour, each hour is about 15 degrees. Is that okay? But now it's not mathematical definition, it's an ancient definition. The mathematical definition is what? For the ratio, same ratio. We talk about 300 degree ratio is for hour, 15 hour, and each hour is about 15 degrees. Okay. Now another people say the ratio I want to use will be the diameter versus the circumference, or your so-called parameter for a circle. That's a ratio you make a circle compared to your diameter. So the total length of this circle here, let me use a green color. So the total length of this circle over here versus the diameter, we call it what pi, we call it pi. Pi equals your perimeter of the circle versus what? Versus your diameter. Right? That's the ratio between these. But because diameter is 2r, so actually you have a perimeter divided by 2r. R is the radius. R is only half of it. It's this red one. It's called R. So you got perimeter equals 2 pi r. Right? Is that okay? That's another ratio. The original definition for that 360 is the number of the sun travel around. So when you make a circle, one circle is 300 degrees because the 360 degrees because they believe that that's the number of days the sun go around the earth, and then they cut it into 24 hours for a day. Now, another smart people actually find out a ratio between that circle and the rate and the diameter as the ratio. That would be the pi. Now we have this. We have this circle again. So let me draw this. There's a radius r. And then here is a circle, right? And then this guy is over here. Here is a theta. We have the cosine, that's green over here, that's cosine theta times r. Here we have red, so this one is r sine theta, right? And then we know that the total perimeter is 2 pi r. Okay, and this theta compared to 2 pi r is the ratio of this part to the whole circle, right? It's a so when this theta is 2 pi r divided by 2 pi r, that will be 1, right? And then if the theta is say like this one 45 degree, so when theta is 45 degree, and then theta is 45 degree, then this 45 degree will be 2 pi r. That will be what? 1/8.
Huh?
Right? 45 degree. The length of this guy will be 45, 1/8.
Oh, yeah. Yeah.
Yeah. So this 45 degree, I'm sorry, this 45 degree with parentheses should be 1/4 pi times r. Right?
Yeah.
Yeah. So when r equals 1, this 45 degree is actually
Pi over 4.
pi over 4. Okay? Okay, let me take a picture of this. Now comes the definition. So let's look at the definition. Okay, this is very important. Okay. I'm going to erase this. Okay, now I have this circle, right? I have a circle. This one is 1, right? And then here is cosine theta. Because I is 1 right now, this one is cosine theta, right? What's the length for the circle's parameter now? Parameter now is actually 2 pi times 1 equals 2 pi to make a circle, right?
Yeah.
So now, let me show you. The whole circle, black one is 2 pi. Half a circle from here to here. The red one is how much?
Pi.
Okay, the red one is pi. That's 180 degrees. Now I have a green one. I go from here to here. How much is green one?
Pi over 2.
So pi over 2 equals 90 degrees. Now I have another one, that's blue one, to 45 degrees. That's blue. -45 degrees. Right?
Yeah.
So what? So 1 pi equals 180 degrees, right?
Yeah.
So pi over 180 is actually 1 degree. Every 1 degree is like that.
Yeah.
So I have n degree equals n times pi over 180, right?
Yeah.
So if I have 45 that divided by 180, that would be 1/4 pi, right? So that's the conversion ratio between pi and the degree. Okay? That's the conversion ratio between, sorry, I should take a picture. That's the conversion ratio between the pi over degree. Now I clean it, okay? Now the first thing we know is that right now is that I have n degree, that actually is what? N times pi over 180 pi, not many pi. This one we call it radian. It's in radian. It's a little bit like radius, so it's a radian. How many radians? And the radian actually means what? If you are on the unit circle, the radians count actually is the length of this guy. The length of the car, which is also the length of R on unit circle. It also is the length of the arc on the unit circle. So I have a unit circle, the radius is 1, and then my angle is 120 degrees. 120 degrees, that's actually 1/3 pi. So this arc will be 1/3 pi. if my angle now is 1/4 pi, then the length is also 1/4 pi. If my circle is half circle, then my circle is 1 pi. Is that okay?
Yeah.
And if my circle is the whole circle, then on the unit circle, my length on the R will be 2 pi. So the radian is also the ratio for arc over 1 on your unit circle. So it's the length of this arc over this 1. It's called the ratio for the called the radian. So this arc is long. The length is 1/4 pi over 1. That's the ratio of this arc over here. So if I have a full circle, the arc is actually 2 pi over 1. So the ratio is 2 pi over 1. Is that okay? Mm-hmm. Now let me show you another thing. This one is on a unit circle. This one is on a unit circle. Now, if it is not a unit circle, what will happen? If it's not a unit circle, we have this. We have a circle. The length is R. This is theta. Here we have the R cosine theta. And this one we have R sine theta. And this guy, arc divided by
1.
Arc divided by R. Okay? It's the ratio of the arc over the radius. This guy is called theta. So the length of the arc is actually R theta. R times theta. And this theta must be in radian. Okay, I don't want to make this chart too heavy, so I just take a picture. This one's very important. Try to understand it, and before, let me know if you still have some, you still not able to understand it.
I think I understand it.
So the ratio, the theta itself is actually the arc divided by R. So this arc length is actually R times theta. Okay. And you used to understand angle as what? Number of degree. That's nothing to do with the ratio. But now we're trying to understand the theta as the ratio. It's the ratio between arc and the radius. So in this chart right here, we have R over here. We have R cosine over here. We have R sine over here. And then we have R theta over here. So that's what. And then now understand why I'm doing this. Yeah. As long as you know about this R, you know about this theta, there's R cosine theta, there's R sine theta, and there's R theta. That's the whole set. Is that okay?
Yeah.
Take a picture. this one is good. Now, now we finish the part for perimeter. We finish the part for perimeter. We are going to talk about area. So right here, I know I have a circle. The circle's length is r. So give me any theta. This length will be r theta. When theta equals 4.5 degrees or 1/4 pi, then my r theta will be what? Will be 1/4 times r. 90 degrees, that would be half pi.
So pi over 2 times r.
Pi r over 2, right?
Mm-hmm.
And then 180 degrees, that will be r times pi, right? 360 degrees should be r times 2 pi, right?
Yeah.
And then I have theta and r theta. I have 270 degrees as 2/3 pi. So actually 2/3 pi times r, right?
Mm-hmm.
So all r times 2/3 pi. So as you can see, right here is always the theta. It's always the theta.
Yeah.
Got it?
Mm-hmm.
Okay. This one is about theta and the arc, the length of the arc, right? Now I'm going to talk about area. So later you probably need to write your own notes, okay? I give you a lot of shot on the screen.
Yeah.
Later you need to organize yourself, okay? Now I'm going to talk about area. I give you a circle. This one we know r cosine theta, r sine theta. This one r theta. Now how about this area? The area of this, what's this? This is called what?
The area of the sector? Oh, pi, huh?
I mean, this is a pi. This is the nickname. This is not a real name. What's the name of the black one?
Black.
The whole area is called what? It's called what? There's a name. Look at the textbook anyway.
For the area?
Yeah, for the area. What's the name of the arc? I mean, that's not arc.
The sector?
The sector, yeah, maybe sector or some name. You have to figure out how the textbook call it. Okay.
Okay.
I really don't know what's your textbook call it, but there's a name for. Let me see. Let me try to check it. Okay. Sundial. Let me see. Your area of. Let me try this. See what is it. Okay, this is called area of sector of a. Okay, you are correct. It's called area of. This is called radian, right? Radian is a ratio between your circumference is that, and then area of a sector. What is this area of this sector? We know theta. What's the area of this sector?
Like 1/2 r squared.
Can you write on the whiteboard? Can you try to write on the
Okay.
I can erase anyway, so don't worry.
Is it? Wait, is the area?
How is the area? Yeah.
Area. Wait.
What's the
Oh,
area? Okay. Give me a
wait.
hint, right? The whole circle, what's the area for the whole circle?
Pi r squared.
Okay, the whole circle is pi r square. Now, okay, the whole circle that. And then what's the ratio of this guy with the whole circle?
The thingy over pi r squared.
What? I mean the ratio of this sector over the whole circle.
Wait, what is that called again?
This area of sector, right?
Yeah.
This sector over the whole circle area.
Yeah.
What's the ratio?
The
whole circle is 2 pi, and this one is only occupying theta because the ratio that's the ratio of this one to the whole circle, right?
Yeah.
Yeah.
So then
it's what?
R 1/2 r squared theta.
Yeah, it's called 1/2 r squared theta equals 1/2 r times r theta. Right?
Yeah.
Okay, I'll explain this later, but keep this one for now. It's called I will erase part of it, not the whole thing. Okay, let me erase this part. Let me choose to go faster. Okay. Erase. Wait. This side. Okay. Just erase it. Okay. Now we know the area. This is RC. Okay, and the area where it's like now is called half r squared theta equals half r times r theta, right? And then it actually also is the ratio is theta over this times pi r squared, right? That's one way to look at it. The other way to look at it is this area A. This area A is actually half r times arc. And this arc is this is the arc. This is the arc. This is the arc. So half r times arc, and the arc is r theta. If we look at this like this, we say this is theta, this r theta. This is like here you have the r, so it's just like a. Let me show you. Let me change to blue ink. Let me change to blue ink. It's actually like a triangle. You have a base, you have a height. The area of this triangle is half height times base. So now this one is like r. H is similar to r. This one base is like r theta, the arc size. Is that okay?
Yeah.
So you think about this like a triangle. The red one is like a triangle. So the height of this guy is r. The base of this guy is actually what? R theta. So that's the area for this. Okay, let me erase this. Let me actually this time erase the whole thing. Let me change to black one. Okay. Now let me redraw that unit circle. I call this unit circle. So here I have this unit circle. We got 1. This guy is cosine theta. I'm sorry, I don't call it unit circle. Let me pick this one as tensor of r. And this r sine theta. And the arc is r theta. And then the area is a half r squared theta. Okay, this arc equals r theta, right?
Mm-hmm.
And then this guy is a half r times r theta. So that gives you the detailed information for a piece of pie. You have the theta and the area. You got the area. You got what? And the triangle area. What's the triangle area?
Base times height over 2.
Yeah, so it's the r squared sine theta times cosine theta. Right? Right?
Yeah.
For the triangle, right?
Mm-hmm.
Yeah, that's actually this. So you get this area. Let's call this B. B part is blue. So this is B, right?
Mm-hmm.
A part is red. So A part is like this, right? The whole thing. Right?
Mm-hmm.
So that's the detailed analysis about the length and each segment and area for a segment, a sector on a circle. Okay.
Okay.
Now let's go back to trigonometry. That's a detailed analysis for that. Let's go back to trigonometry. Okay, now everything started from sine and cosine. So here we have this. This one is 1. This is theta. This is cosine theta over here. This is sine theta over here. And then tangent theta is sine over cosine. Right? And the theta is over here. So tangent is perpendicular. T, perpendicular. Right? So when you try to find a triangle, you have a theta, you find where is the perpendicular one. Your base and the perpendicular one. This ratio is called sine over cosine theta. It's actually your tangent T. Okay. You have a triangle, theta, this is cosine. You have a theta, this is sine. You have a theta, this one is your tangent. Okay. And tangent is always what? Perpendicular to something.
Tangent is perpendicular to the x-axis. Wait,
So
no.
here,
Yeah.
yeah, so it's actually this versus this. Perpendicular direction. Got it? That's a perpendicular direction. Let me see. I copy to you. Yeah, I copy to you for the perpendicular one. Now, these three, we come from these three. We have the sine, cosine, and so sine, cosine, and tangent we define. Then second theta equals 1 over cosine. And then cosecant theta equals 1 over sine. And then cotangent theta over 1 over tangent. So we basically come from sine, cosine are most important. Sine, cosine more important. And then we got t, and then we got all of the rest. Okay. And to be honest, only these three are more often used. The other three seldom been used. But we got to know about the name for different things on a circle. Okay, let me erase this now. Let me erase this now. So we have a circle. We have a circle. Here is something cutting it. There's a perpendicular direction. Here is your radius. This guy called tangent line. Is that okay? That guy called tangent line. So as your tangent line can also draw this. There's a single theta, the ratio of this to the tangent line. It's called tangent.
Yeah.
There's another line. It's not actually outside, but this guy actually cuts through it. This guy is called secant. Right? I'm sorry. Right? This guy is called secant. There's a secant line.
Yeah.
And then there's another line. Let me use it. What's this? Right?
Oh yeah, chord. Oh yeah.
What's this?
Yeah.
Chord is because why is called chord? Why is called chord?
Why?
You have a ball shooting an arrow, and what's the name of this?
The arrow?
No. You have a ball. I don't know what is this English should be. You have ball, right? This is ball, right? This. And what's the line here?
I don't know.
Why?
Is it a chord?
Wait, this is not what we. Yeah, this is a hot chord. This is a chord. The length of this is called CHORD. The length of this to this is the whole chord. This is R, that's chord. Right? So the chord is like here is you have a ball. The ball length, all distance is here to here. It's called chord.
Okay.
Got it?
Uh-huh.
Let's go chord. Let's go chord. Tangent line, second line. Right? That's the name you need to know about circle.
Okay.
So basically, all of the theta angle, cosine theta, sine theta, they are all ratios. They are all ratios. And the word radian means it's actually not a real unit for a measurement for the length, but it's a measurement for ratios.
Okay.
So when we talk about 2 pi, it's actually not the length is 2 pi, but it's actually is the ratio is 2 pi. And when we time a r, that becomes the real length. That's become the real length. I gave you this already, right? Okay. I gave you this, yes. I'm going to clean this. So sometimes when we have a circle, we have a theta over here. This is r. We call this r theta. Sometimes we also call this as s equal r theta. So this is a ratio. This is a radius.
S is a second.
S is your distance.
Oh, okay.
So there's a stupid guy making a circle. How far he run? Right? He run half a circle, so he run actually. He run half a circle, so actually run I times r. Let's call s. So s equals. So s is actually the length of r, and it's also called the distance, the travel distance. Is that okay?
Okay. Yeah.
Now I'm going to try something more interesting. Now let me give you. Okay, let me try something interesting. Now I have something called what's the name of this?
Pentagon?
Regular pentagon. I assume the angle is the same. There's a center going to here, going to here, going to here, going to here, going to here. What is the measurement for this theta if it's regular?
The angle. Oh, wait, do you do?
You have a circle outside cutting it like this, right? So the total is 2 pi. So the angle will be 2 pi divided by 5. Right?
Yeah.
So that's the angle.
Oh.
Or your theta can say 360 divided by 5 if you like the degree. Right? Now, tell me, before we jump into something more difficult, tell me about this. What's the area? What is the area for this? Actually, let me draw this sector?
Oh, it's 1/2 r squared theta. Right?
So if you know this r, you know this, right? If you know this r, you will be 1/2 r squared theta, right?
Yeah.
Now, if I'm not really happy, I give you side, I don't give you r. Then what's the area for that single one? The whole pentagon will be this guy times 5, right? So we know that.
Yeah.
No, whole circle, I'm sorry, whole circle.
Yeah.
No, I don't need this. Actually, I have this side. So what if I give you the side? What's the area for this? I don't know about.
Wait, is the side of the circle or the pentagon?
The side of the sector of the circle.
Oh, 1/2 r times s.
But I don't have r. Now I have s.
Oh, 1/2
So actually,
s over r.
this
Wait, no,
s 1/2 over s equals what?
r
Times
theta.
r times what? Sine
Oh yeah.
half theta, right?
Yeah.
This is actually so this is actually size equals 2r times sine half theta, right?
Yeah.
So by that relationship, you can use s to find out r, and then you know r and theta already, so you can basically solve the area for that circle. And also, you can also use that to solve your triangle, right? Okay, now I erase this. Okay, now I erase this. Now I'm going to draw this again, a pentagon. Whatever pentagon it is, okay? Here, I have the theta. But let me cut into here half. Theta, theta, half theta, half theta, okay? And here, so this is r. This guy is called r sine theta, half theta. This guy is actually r cosine half theta, right? So the area for this group R, this guy, the group R, the whole this 1/5 of a pentagon, 1/5 of pentagon, this triangle, blue triangle. The area for this is equals half r sine half theta. Wait, no, actually this should be 2 times 2, right? Because the base is times 2 times r cosine half theta. Right? So it actually is half, actually it will be 2r squared sine half theta times cosine half theta. Right? And then actually 2 sine half theta times cosine half theta actually equals cosine theta, equals sine theta. So the area actually is half r squared sine theta.
R squared.
The tricky part is the middle part. Is this 2 sine theta half theta times cosine half theta equals sine theta.
Okay.
Yeah, that's the tricky part. This guy is this. So actually this is this. Okay, let me erase this. I give you the picture already. Let me erase this. Let me try again. Try again in different way of doing this. Okay, let's assume this is 1/5 of this. 1/5 of this pentagon, right? And this is half of it, right? So here is actually this guy is cosine theta half theta, r cosine theta. This one is r sine half theta, right? And actually the whole thing from here to here has 2r sine half theta, right? And the area for this guy is actually half, and then this guy base. I'm sorry, the whole thing for the whole area for the whole thing is actually base is 2r sine half theta times cosine half theta times this is r over there. So this one is actually half r squared 2 sine half theta times cosine half theta. This guy actually is half r squared sine theta. Because this guy over here equals sine theta.
Okay.
And this actually you can find sine 2x. Okay, so it's sine 2x. Sine 2x is 2 sine x times cosine x. So sine theta, if theta is 2x, so sine theta is 2 sine half theta times cosine half theta. 2 times. So now x equals actually half theta. So theta is 2x. Is that okay?
Yeah.
So that equation we just see. So here is the sine theta equals 2 sine half theta times cosine theta. And then over here, it gives you this. So let me actually. And to prove this later, I'll show you how to prove it. But for the time being, just to remember this. For the time being, just remember this. Sine theta, 2 theta equals something like that. Okay. And then the area for that is this.
Okay.
Anyway, why am I doing this? What's the purpose of doing this?
So I know the area.
Area of the something inside the core, right?
Yeah.
Something inside the core, you can do this. Now let's look at the whole bigger picture. Let's look at the bigger picture. Okay. Small picture, you don't know what's going on. You actually don't know. Now I try a circle again. No matter what circle it is, the length is r. I have a theta. The area is half r square theta, right? And then right here, I have another one. This one called phi. And I'm trying to figure out the area for this triangle in blue. That area is actually half r squared sine phi. Yeah? What was that?
The area of the part inside the chord. Wait. Wait, is the circle with the line through it the same thing as theta?
What?
Is the circle with the line through it the same thing as theta?
Circle in blue?
Yeah, wait, the circle over, like, on the side that you circled? Like, yeah.
Okay, I'm talking about the area of this sector. Of this sector is this, right? There's no problem, right?
Yeah.
So for a sector. But for a triangle, and then I use the phi. And then
Wait, what's that?
And this is the area of the blue one.
Oh.
Area of blue one, we just prove it, right?
Yeah. Oh, yeah. Oh, yeah.
Right?
Yeah.
Area of blue one, we just prove by this.
Uh-huh.
Actually, if this is the whole thing is a theta, and then we use a half cosine theta, cosine half theta, sine half theta times r, and then the whole area for this circle, and this is chord. Inside the chord is a triangle, r, and chord, and then here is theta. So this one, r, and chord. So basically, you have something like this. You have something like a pi, right? A pi. You have a pi, certain sector of this. The area for the whole thing is called half r squared theta. The whole, and then this one we saw that is actually half r squared sine theta. That's what I'm trying to say.
Okay.
Right?
Okay. Yeah. Yeah.
And the one cut to here is what? The line cut to here, the triangle. That means that this one is too busy now. This one is actually too busy now. I need to try to copy this thing for you. Clean up, okay? Now actually we have this, right? This theta, this is r. The length of this guy is r theta. We have this. The length of this guy is called r sine theta. The length of this guy is r cosine theta. There's a blue one up to here, right? The length of this guy is 2r times sine half theta, right?
Uh-huh.
And then the area of this gray one and this
is 1
half
square theta.
The blue one right?
Uh-huh.
The green one
Yeah.
Yeah?
Yeah.
That will actually help you to understand how to calculate a different area and length for each segment when there is a circle involved. Some section of it, how to come up with the area and the length real quick. And that is actually the purpose of learning trigonometry. You will be able to calculate different area and angle and actually the ratio here there to analyze the geometry.
Okay.
So it's part of the, we call it part of the analytical geometry. Or some people call it coordinate geometry. So you learn geometry, you learn algebra 2, now you started look at the analytical geometry or coordinate geometry. And today I just give you a short introduction on the topic of trigonometry. And let me look at your chapter. Where is your book? Okay, this one I don't need it. Where is your book? Oh, not this one. Okay, I give you this. Okay, this one. The test is right here. So let's go through this the ratio here, whatever you can actually read it, okay? I don't think that's too hard. With the angle ratio, you can study it. I don't think that's a problem. Okay, 91. Okay, 91. Oh, okay, here is a hexagon. What's this? That's a hexagon, yeah. I give you the example by pentagon, but this you need to think about hexagon situation. So hexagon, each one is what? 60 degrees.
30 degrees.
It's a 60 degree, right? Half theta is so area for this this is actually R is 1, right? 1. If R is equals 1, so that area for this guy, 1/6 of the hexagon, would be half R is 1 square, so it's gone sine 60 degree. That actually is what? Square 3/2.
Yeah.
Yeah. So this one square 3/2 times 6. That's a 3 square 3. That would be area for a hexagon.
Okay.
Right?
Yeah.
So that's something you actually can quickly apply. And then if somebody say there is something called 18 gang, 18 side. So what should you do? Half R squared. The 1 pi of it, 1/18 of it would be half R squared times sine theta, and the theta would be 2 pi over 18, right? And then half R squared times sine 2 pi over 18 times 18, you will get the area for that. 18 gang, whatever name it is. Wait, this textbook is stupid. Extremely stupid. Chapter 9. We finished that one. Angle and the radian measure. I told you already that's a ratio, right? I told you that's a ratio.
Yeah.
And the ratio between that is when I have a degree, I have n degree. That should be n times
pi over
180. Yeah. Okay. On the other way, if you have a certain ratio. You know the theta in radian should be times 180 over pi that give you the number of degree. Yeah. Okay, that's one. It's okay. Now you know that. Then if the angle is more than what? Is more than 90 degree. What should you do about sine and cosine? Okay, this one, let me erase this. If the angle is more than 90 degree, what should you do about the sine and cosine?
It doesn't work, right? It has to be 90.
No, it works.
Oh.
It is defined as, I told you before, actually.
Oh.
There is a unit circle. Right here, this one's 1, this is cosine theta, this is sine theta. This point is called cosine theta, sine theta. Theta is over here. Now there's another one right here. There's another one right here. This one called phi. This point is called cosine phi, sine phi.
Oh yeah.
Right?
Yeah.
So actually cosine phi is this, but it's negative. And sine phi is this. Coordinate of the point on the unit circle. Sine phi and cosine phi define as
Sine.
Coordinate on the unit circle. So if the angle is on the first quadrant, it will be on the first quadrant. It should be positive. On the second quadrant, it will be minus positive. Third quadrant, minus. Fourth quadrant, plus minus. Okay, that's a definition for the trigonometry, the sine and cosine. If the angle is more than 90 degree or less than 0, all of them has the definition. As long as you know what quadrant it is, there is definition for that actually. Okay, let's go back to the textbook now. Textbook. So we talk about the angle, different angle. This one is called terminal angle. What's the terminal angle is?
It's like an egg, like the degree, and you can add 360 or minus.
Yeah, so yeah, whatever. That's not hard. Okay, that's not hard. That's actually not hard.
Yeah.
Radian, I told you already. Radian. Right?
Yeah.
And this one, core concept, the arc length and arc length. I told you, and sector area. I told you, right?
Yeah. Yeah.
That's the ratio I teach you already. So this one, okay. And then not only that, but also
the core.
The core inside the core area and core length. Okay. Not all covered. Let me show. Let me show this one is actually covered. So this one covered, this one covered. Wait. Now this one probably okay, right? Now let's go to 9.3. See if we cover 9.3 already. Let's go to 9.3. Trigonometry function. Oh, okay. This one I just told you. The definition is by the x over r and y over r. Actually, I emphasize this quite many times, right? Yeah. So this one should be okay. Let me see this one. Okay. Okay, I think that 3 is also okay. We cover that. You work more on your homework, okay? And then next time you finish the blue book I gave you.
Okay.
Okay. Now the next one is graphing, sine, and cosine function. Okay, this guy next time. Okay.
Okay.
We finished up to 9.3.
Yeah.
9.4 next time. Next time we talk about this graphing part.
Is the graphing part harder?
No, I don't think so.
Okay.
Yeah. I don't think so. Next time I try to finish 9.4 to 9.6.
Okay.
And then it's the trigonometry identity. Trigonometry identity is the one we just use the sine 2 theta equals something. Those are called the trigonometry. That's actually called the identity of the trigonometries. And then it's almost there. Okay. Almost there to finish in chapter 9 for algebra 2 level. Okay. So thank you now.
Okay, thank you.
You work on the portion that you should finish on the algebra 2 I gave you, okay?
Okay.
Okay, bye-bye.
Bye.